Yes. Hello. Am I audible? Yes. 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 Thank you. Okay. Okay. Not a problem. Not a problem. So is it visible? Slide is visible? Okay. 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 Thank you. So myself, Dr. Saurabh Rana from Department of Statistics, Vishwabharati, and today I will discuss on the topic Introduction to R and its application on dynamical systems. So I will go through very basic ideas of R and why it is needed and like this. And after that, I will very briefly discuss how a discrete system solved, and then I will go for the continuous system. And specifically, I will discuss mainly three problems which usually we use in our research papers for continuous systems. So I will discuss those. So RStudio, why we use R or RStudio? So these are basically open sources and free, and it has extensive library support in mathematics as well as also statistics, and it actually requires less space and it quickly starts if you compare to other kind of programming languages. It has some user-friendly interfaces. Mobile app is also available, so it has some lightweight programming. So if you want, you can just uh, use your mobile and you can run all those codes which I will actually discuss here. So you can also use mobile to check it if you have some uh, laptop or computer related issues, then you can use it on mobile. And it has some kind of Markdown and Shiny supports. So those step I will skip because you already know how to install and like start R and save new files. And R has a huge mathematical as well as statistical supports. So you can perform various kind of operations on that. So it includes some mathematical operations, vectors, and like matrices like this. And for solving discrete time dynamical systems, we need actually for loop. So if you know the for loop, then you can easily develop and solve your discrete type dynamical systems easily. So this for loop actually uses a statement and a sequence of numbers. So suppose you want to add 1, 3, 5 up to 99. So you need to create a sequence like this. So you need to, if you create the sequences 1, 3, 5 up to 99, then you can just easily sum up those numbers and you can find the sum using for loop. For discrete time dynamical system, I will go through the one-dimension discrete map. So here the system is the logistic system. This is xt plus 1 equal to r into xt into 1 minus xt, where r is the parameter and x is the variable, and with the initial value x equal to 0.1. So you can easily solve this by using for loop. So here, as you can see, you just write down the model, specify the parameter and the initial value, and just use the for loop. You can find out the solutions of that model, and you can just plot it in R. So you can easily solve this kind of equations. For 2 dimension, you don't need to do a lot of things. So here, instead of one equations, you just put 2 equations and 2 initial values, and the rest of the code is same. So you can easily draw this as well. So here I have demonstrated this. So for r equal to 2.5 and length equal to 50 means the time point is 50. So here for r equal to 2.5, the graph looks like the above one, and for another r, so for r equal to 3.1, the graph looks like this. Okay, so you just change the variables and you can see different kind of graphs. For bifurcation diagrams, actually what we do, we just vary a parameter and see how the system behaves in a long term. So here what we will do, we will just fix the time. So the system simulates up to 400 times. You can just change it, and here the initial value and n equal to 50, 500 means suppose your parameter range is say 0 to 4, then within 0 to 4 you will check 500 points of those parameters, and l equal to 50 means last 50 point we will check. And here actually a consecutive for loop is needed. One is for parameter, another one is for system. So if you use those consecutive for loop and solve the system, and just save all those parameters and plot, you can just find the bifurcation diagram like this. So the main part which I will discuss is continuous system. So continuous system, I will discuss mainly 3 problems. First problem actually based on the model which I have published. Actually, this is a modification of Hastings-Powell model. So here the main objective is solve. So this is a 3-dimensional system. So solve and draw time series plot of each variables. So this is a 3-dimensional system. So you can use R to solve the time series. So solve the system and draw the time series. Another one is that time series plot in a single graph. So it looks like the right bottom graph. So if you want to draw in a single graph, so how to do this? And last one is 3D phase diagram. So actually Hastings-Powell and these are all these extensions graphs are actually famous for their chaotic attractor, which is some 3-dimension phase plot, and this is known as the famous teacup attractor. So I will discuss all these